Let's look at trigonometric ratios for compound angles. So here you will come across this sine A plus B, sine A minus B, cos A plus B and cos A minus B forms. So trust me, these are 4 formulas, right? Only 4. From these four, you can derive about 50 to 60 more formulae in this chapter. So once you memorize these 4, you should just know how to apply these to derive all those other cases. So those 50 to 60, so I'm just giving a large number here. I've not really counted how many are there, but all the formulas of this chapter that are to follow, like multiples formula, like formulas like sine 2a, sine 3a, formulas like cos 2a, cos 3a, tan 2a, tan 3a, everything. Something like sine A plus sine B, like so many of them. All those formulas, they just use these four that are right in front of you. Sine A plus B is equal to sine A cos B plus cos A sine B. Sine A minus B is equal to sine A cos B minus cos A sine B, right? Sine cos A plus B. Now this is tricky. You have a plus here. So with sine, if you have A plus B, then you'll have a plus in the middle. If you have A minus B, you'll have a minus in the middle. But when it comes to cos A plus B, if you have a plus in the middle, you have a minus here in the middle. If you have a cos A minus B, if you have a minus here in the middle, if you have a plus in the middle. These are things that you need to look at and memorize these 4. From these 4, you can actually derive everything. In fact, I won't be deriving all of them for you. I'll just state them for you, and I'll just pick up a couple of them and show how these 4 can be applied. One of these 4 can be applied to derive that's there in front of you, right? So also, I hope that you remember these identities from your 10th, the trigonometric identities, like sine square theta plus cos square theta is equal to 1, right? I hope you remember this identity. This was done in your 10th. Also, you have this one more identity, 1 plus tan square theta is equals to secant square theta, right? This was one more. And the third identity was 1 plus cot square theta is equal to cosecant square theta, right? So these 3 trigonometric identities as well. There's no separate section that's needed for these 3 because you've already seen this before. So just remember these 3 identities also. Remember, trigonometry is a particular topic which does not have a lot of understanding like it does in sections, like the module that you had before. Also, there are modules coming later where you have things like inverse trigonometric functions, where you have to have some in-depth understanding about the procedure. Things like trigonometric equations also, which require a little understanding. But I would say it is about 30% understanding and about 70% of memorizing. 70% of memorizing, and not just direct memorizing. Like, I'm not expecting you to remember all these 50, 60. Just like some of you are capable of doing that, some of you are not. But do you know how you memorize these 70%? You just solve a lot of problems. So you pick up these 30, understand, and then you just try to memorize how much ever you can, and then you apply them so many times in so many problems. All these formulas, all these trigonometric formulas, these identities that you see, these 4 formulas and the 50 to 60 that are to follow, you apply them so many times in the problems that it just gets registered in your head. So remember, without practice, you can't memorize these formulas. You just get confused with signs. Like, you might just go wrong with this plus and minus. If you just memorize it blindly, you might just go wrong with this plus and minus. You have to practice it so many times that your hands get used to these formulae, right? So trigonometry is a lot of memorizing. I need to tell this to you from before, right? That's how we were taught. So the way I was taught trigonometry is I was given these formulas, these 4, and then after this a list of all those formulas, and I was asked to just sit and derive those 50 to 60 from these 4, right? And then use them in the problems, and that's how I'll be able to memorize. So that's what actually happened. That's how it goes. Let's move on to looking at those important results now. So here we have a few results: tan A plus B, tan A minus B. Likewise, if you remember this, you can also memorize cot A plus B and cot A minus B. So tan A plus B, how do you get this? Tan A plus B is sin A plus B by sin A minus by cos A plus B, right? So you already know the formula for sin A plus B, you know it for cos A plus B, right? So you will write them, and then when you take the terms common, you'll be able to derive this, right? So I'm now going to the reverse derivation and just showing you how you can derive it. Cos A minus tan A minus B, it's very simple. Sin A minus B by cos A minus B, right? You know the formula for sin A minus B, cos A minus B. Again, you'll put them, you'll take the terms common, you'll be able to derive this. Sin A plus B into sin A minus B. You know the formulas for sin A plus B into sin A minus B. So you will write sin A cos B plus cos A sin B into sin A cos B minus cos A sin B, right? So it is A plus B into A minus B form. So you'll write this in the form of A square minus B square. And then finally whenever you use the inequality, sin square A plus cos square A, the identity, sin square A plus cos square A equal to 1 and sin square B plus cos square B equal to 1. So if you remove from these two and from the A square minus B square, if you remove cos square A and if you remove cos square B using these two identities, you'll be able to get this result. Likewise, you can also derive this particular result, right? Tan A plus B plus C is not very difficult. Tan A plus B plus C can be written as B plus C as common. So tan A plus theta, you can treat it as tan A plus theta. Use this particular formula, and then tan theta is your think of tan A plus theta. So this will be tan A plus tan theta by 1 minus tan A tan theta, and then tan theta is your B plus C. So tan B plus C, once again you can write this as tan B plus C, and then use the formula for tan B plus C, which is of the form tan A plus B. You can use that formula, and then finally you'll be able to get this result, right? Likewise, you can also have cot A plus B, cot A minus B. Cot A plus B will be just 1 by tan A plus B. So you already have tan A plus B with you, right? You can just take 1 by that. So it will be 1 minus tan A tan B divided by tan A plus tan B. And in fact, you can write this in the form of cot. So like if you write, instead of tan, if you write 1 by cot A and 1 by cot B, so you can write this as 1 by cot A cot B, and you can write this as 1 by cot A plus 1 by cot B, right? 1 by cot A plus 1 by cot B. So if you do that, you'll get the result as cot A cot B minus 1 by cot A plus cot B. Likewise, you also have the formula for cot A minus B. You can look for that in your textbook, right? So in fact, if I were to state it, you can just derive it from here. It's not very difficult. So cot A cot B plus 1 divided by cot B minus cot A. So that is the formula for cot A minus B. I would like to I would like you to look at this. This is cot A minus B, but in the denominator you'll have cot B minus cot A. Here it's cot A plus B, and in the denominator you'll have cot A plus cot B. So if you write this as cot A minus cot B instead of cot B minus cot A, you'll go wrong. So you have to memorize the formulas as it is, like how they are. If you get confused, you can always get into the derivation mode and you can derive as to what it is. But I would suggest you memorize, because in the exam you'll just have to use them directly. You won't have the time to derive. So these were a few results. Let's move on to the range of f of theta, which is like when you have functions like a cos theta plus b sin theta is equals to f of theta. So as you can see, it's a function in theta, right? If I can give theta as my input and I'll get f of theta as my output. Let me see what are the maximum and the minimum values possible for this.